All right. Welcome back. We are live. I'm Dr. Boyd, the chemist, and I'm a research scientist. And we are doing this is lesson 27 in week 6 of these homeschool science lessons. So here's what you'll need for today. Today, we're doing dancing raisins, and there's 2 ways to do this, all right? So I'm hoping that if you can't do it one way, you can do it the other way. And if you have all the materials, you can try both methods, okay? First method, you're gonna need raisins, you're gonna need soda, or what I call pop, and you're gonna need a glass, and that's it, all right? The second method, you'll need vinegar, you'll need baking soda, or about a tablespoon of baking soda, and you'll need a glass. And that's it. Okay, again, we're doing dancing raisins today, and there's 2 ways to do it. So the first method requires raisins, soda or pop, and a glass. Or you can do it the second method, which requires vinegar, baking soda, and a glass. All right. And if you don't have raisins, you can substitute the raisins with grapes. It should work. It may not work as well, but it should work. So if you have a grape or two, this should go forward just fine. So again, we'll start in about a minute and a half. We're doing dancing raisins today, and this is what you'll need. All right. Yes. In Michigan, we call it pop. Oh boy. Although I feel soda slipping into my language more and more the longer I'm away from the Midwest. Soda. All right, we're going to go ahead and get started. Again, I'm Dr. Boyd, the chemist. I'm a research scientist, research chemist at the Naval Research Lab in Washington, D.C. I primarily deal in polymers these days, but for these past 5.5 weeks, I've been doing these homeschool science lessons, and I hope they've been a benefit to everyone out there, trying to give the parents a break during their day, or at least give them something educational that they can present to their children, and trying to give the children something to learn, okay? And the children, the age group I'm focusing on is kindergarten through 5th grade. And I know that's quite a range there, but I hope that children within that range find these videos and these lessons valuable. I'll start, I guess, by saying that if you have missed any of the lessons and you'd like to catch up on some of them, you can go to my YouTube channel. Go to YouTube, search for Dr. Boyd the Chemist. The videos are there for the first several weeks, and all of them will be posted by Monday, including this week's. So I have them listed in playlists called Homeschool Science Lessons, and you'll see them listed by week 1, week 2, week 3, week 4, and so on. And so check that out. Also, if you're not following me on Instagram already, follow Science Made Simple _LLC, and you'll see more content that I do just for children, primarily for children at least, posted there on Instagram. All right, so we've already discussed what you'll need, but I'll just briefly say it again. We're doing dancing raisins. That is our experiment today. You'll need raisins or grapes. You'll also need soda pop. I'll say it that way, right? And a glass. That is the first method, first way we'll do this. The second way will include getting vinegar, baking soda, and a glass. And we'll try it that way also and hope that it works for everybody live. So Before we get started, each lesson we try to focus on a few things, and I want to make sure we emphasize them because they're very important. So, what is the most important thing that a scientist must pay attention to whenever they do any kind of experiment or reaction? All right, now if you said the most important thing is safety, then you are correct. Safety is the most critical and important thing that I must pay attention to whenever I do an experiment, no matter how seemingly easy or safe it seems. I need to consider in my mind, how can I execute the experiment the safest? All right, so we've seen what we're working with today. I would say that the most dangerous things we're working with are the baking soda and the vinegar, which for the most part are not that dangerous, meaning that I don't need to wear splash goggles, I do not need to wear gloves on my hand, and I don't need a lab coat. Now, you might want to wear splash goggles because, of course, we wouldn't want vinegar to get into our eyes. So if you have them, that would be a reasonable precaution to take, but I don't deem it necessary for the amount of vinegar we're using and for the method that we'll be employing. All right. But if you do, I would not fault you for wearing them. All right. The other thing that we discuss each time is bringing our lab notebooks. So, do you have your lab notebook? Do you have something to write on? Do you have something to write with? If the answer is no, you can run and go grab some really quickly because it's important that you take notes. All right, taking notes is very important. Whenever I go into the laboratory, I need to take notes before I go and then while I'm there. So, before I go, or at least before I start my experiment, my notebook might be in my lab already. So before I start the experiment, I write down things. I'm writing down what my topic is or what my focus is. In this case, we're doing dancing raisins. I write down what I need. So you may have already written in your notebook that you need soda pop and you need raisins, okay, and you need a glass. So you write that down in your notebook, and then you also write down what you're going to do. All right, your procedure. What are you going to do? Then you want to write down the question that you are trying to answer. Okay. And then when you write that down, write down what you think is going to happen. That would be your hypothesis. Okay. Now, your hypothesis is, in simple terms, an idea that you can test, or a prediction that you can test. Or if it's easier to remember it this way, it is a guess you can test. A lot of times when people answer the question, what is a hypothesis? They say it's an educated guess. That's only partially right. An educated guess still isn't tested, right? You can guess anything, but you won't have a test for it necessarily. That means it is just a guess. What makes it a hypothesis is the ability to test it. Okay, so if I can test it using very specific or very clear, what we call controls, where I'm isolating one particular aspect of what it is that I'm looking at, then you have a hypothesis because you have a guess you can test. All right. Today, what we will do, this one is probably the simplest experiment we have done to date. All right. So I have my glass here. Pardon me. I have a bag of raisins. I've even got, I know we think of raisins as being like dark purple in color, but I've got some golden raisins here. I'll show you. I've got some of these like yellowish looking, what they call golden raisins. So I've got a bag of raisins and I have got some generic soda pop. All right. Now, what I'm going to do is I'm going to take the soda pop and put it into this glass. All right. Then I'm going to take my raisins and put them in the glass. So, your question, what is going to happen to the raisins? That's a very broad question, very broad question. Most of the questions we've asked throughout these 6 weeks has been a lot more targeted than that, but I think we can have a little fun with it today. So I'll just ask the question broadly. I'm going to put soda pop in this glass, and then I'm going to put raisins in the soda pop. What is going to happen to the raisins? All right, let's test it out. Oh, listen to that sound. All right. So I have poured my soda pop into the glass, and now I'm going to put my raisins in the glass. Did you write down what you think is going to happen? I hope you have. Here we go. Let's see what the raisins do. Ah, check it out. I see raisins going from the bottom of the glass up to the top of the fluid. You see that? Look at that. They go up and then they come back down. And they go up and they come back down. And they're all down. Up. And I hope you're all able to see that, right? My folks on Instagram, are you able to see what's happening? I'll check. All right, so we've got raisins, and we're calling them dancing raisins because they're doing this dance of going from the bottom back to the top, and from the bottom back to the top. And the process is repeating over and over again, and it seems like it's going to keep going, right? Here we go again, back to the top. The bottom. Oh, didn't even go all the way to the bottom this time. Just came kind of part of the way down and went right back up. Okay, so did you predict that the raisins would do that? I gave you a pretty open-ended question to answer today. So if you didn't get that one right, I understand. But here's one that's not so open-ended. Why are the raisins going from the bottom of the glass back up to the top? Why is that happening? All right, if you have an idea, write it in your notebook. And I will give you an explanation in just a moment. But think about that. The raisins I have here, soda pop. And I put raisins in it, and then the raisins, instead of just sitting at the bottom, they start floating up to the top. And then when they float to the top, they don't just stay there. They go back down to the bottom. And then up, see, they go back up to the top, and then they go back down to the bottom. Why is that happening? What's going on here? What do you think? Write it down in your notebook. All right, here's your answer. Soda pop is actually what we call a carbonated beverage, a carbonated beverage. That term carbonated means that it has carbon dioxide gas in it. You remember when I opened the top, it went psst. When I opened that top, carbon dioxide gas is being released outside of the container. All right? It has, we call it pop actually because when you open it, it makes a popping noise sometimes. You open a can or you open the top, it makes what they call a popping noise or a sound. That is due to the carbon dioxide gas. Well, that means that this fluid here actually has carbon dioxide gas in it. That's where these bubbles are coming from. Those bubbles, they get caught on the ridges and in the wrinkles of the raisins. And if you get enough bubbles attached to a raisin, the raisin is so light that those bubbles can carry it all the way to the surface. So why does it go back down to the bottom? Well, it goes back down to the bottom because some of the air bubbles, those carbon dioxide bubbles, when they get to the top, they pop and they burst. And so they're no longer holding on to the raisin. So the raisin then is now too heavy to be held by the remaining bubbles. So it goes back down to the bottom. When it goes back down to the bottom, what happens? Picks up more bubbles. When it picks up enough bubbles, it goes back up to the top. And then bubbles pop. And so the bubbles pop, and too many of the bubbles pop, and then it goes back down to the bottom. And this process repeats over and over and over and over again, as you can see. This has been going on now for like 4 or 5 minutes. Isn't that interesting? So it just keeps going. All right, so the raisins are rising because they're being pulled to the top by bubbles of carbon dioxide. And then the raisins sink back down to the bottom because there's not enough bubbles remaining on the raisin to hold it up at the top anymore. And then this process just repeats over and over and over again. All right, pretty cool, huh? Now, we're going to do something very similar. I have another glass. And in this glass, I'm going to pour some water. All right. I got some water here. I want to pour water in. I forgot to mention in my instructions here that you needed water. My apologies. I write it on the board just in case people join later. You'll need water. Pardon my terrible handwriting. All those days where the handwriting was really good over here, that was my wife. She wrote that. When the handwriting has been bad, it has been mine. All right. Now, I have water in this glass, and what I'm going to do is I'm going to get some baking soda. I say about a tablespoon. You can eyeball it. This is really cracking me up over here. This is still going, by the way. These bubbles are pulling that all the way up to the top. Just want you to see that as I do this next part. So again, about a tablespoon of baking soda should do it. All right. Maybe add just a little more water. Yeah. Okay. And what I'm going to do is I'm going to stir that in there pretty good. I have my wonderful, trusty glass stirring rod. I'm just going to stir this up quite a bit so that the baking soda is mixed pretty well in the water. You don't, obviously, I don't expect that most people will have a glass stirring rod like I do. So you can use a spoon or a knife or something to stir with. Okay, now what I'm going to do is I'm going to pour some raisins in here. And when this clears up a little bit, you should be able to see the raisins sitting there inside of this container. Now, when I put the raisins in at this point, what do you think is going to happen to the raisins? Write it down in your notebook. What do you think will happen to the raisins when I put them in at this point? All right, so that's clearing up pretty well. I'm going to go ahead and put some raisins in. All right, I'll even put a couple golden raisins in there. All right. Now you can see, by the way, this is still going over here. You see these raisins? They're just steady going. Interesting, right? It's pretty cool, I have to admit. Okay, so as you can see, these raisins are just sitting at the bottom of this glass here. They're just sitting there. They're not going anywhere. Now, I'm going to add vinegar to this container. What do you think is going to happen? All right. Hopefully you're writing that down in your notebook, and I'm going to pour the vinegar in. And now we wait. Oh, you see what happened? I see a raisin. It's up at the top now. See it? And it went back down, up, and it's going back up. And it went up. All right, so we have something very similar occurring, right? We see the raisins going from the bottom up to the top. Now remember, when I just had water and baking soda in this container here, the raisins just sat at the bottom, right? Once I added the vinegar, I saw something that looked very much like when I poured the soda pop in this container. There was a lot of bubbles and a lot of fizz, right? Then the raisins that were sitting at the bottom, happy to be sitting at the bottom, started going up to the top. All right? Why? Well, the answer should be pretty obvious now. It's the same thing that's happening here. These raisins are being pulled to the top by bubbles of gas. And you might recall that I made a balloon. I filled up a balloon. I think that was lesson 10. I filled up a balloon with gas, carbon dioxide gas. And the two things that I used to make that carbon dioxide gas were baking soda and vinegar. All right. And in that lesson, I'm pretty confident that was lesson 10. In that lesson, I explained that carbon dioxide gas is formed because vinegar, which is diluted acetic acid, when it combines with baking soda, which has in it sodium bicarbonate, that bicarbonate and that acetic acid, they get together and they form this compound we call H2CO3, all right, carbonic acid. And that carbonic acid spontaneously breaks up into two different things. It breaks up into water and it breaks up into carbon dioxide. Believe it or not, that is how you end up with carbon dioxide in your soda pop. It is also carbonic acid. And so we have made carbon dioxide gas by combining vinegar with the baking soda. And that carbon dioxide gas is doing the same thing in this container as it's doing with the soda pop. And it's bringing the raisins from the bottom to the top. And this process just keeps repeating over and over again. And because it's kind of a continuous process, we call it dancing raisins. All right. That is our lesson for today. I hope that you got something out of this, and I hope you're having fun with this. If you have soda pop, hopefully that you have enough that your parents will let you play with it for a little while. Or if you have these components here, maybe they won't care as much that these are wasted. You might want to drink the soda pop, right? Okay. I will see you tomorrow at 2 o'clock Eastern time. Again, if you want to see all the videos from these past several weeks of experiments and lessons that we've done, you can go check me out on YouTube. You can search for Dr. Boyd the Chemist. All the lessons are there listed by week in playlists called Homeschool Science Lessons. Definitely share it with other people who may be interested in doing these types of experiments at home with their parents or with their children. And definitely subscribe to the channel. Also, you can find me on Instagram at ScienceMadeSimple_LLC. I've posted all the experiments, what you need for all the experiments, and which day they were done. I posted all that on the Instagram page. And with that, I will see you tomorrow. Take care.